High-performance computing gives us the potential to, let's say, go beyond the national limitations of, let's say, experiments, tests and predictions. So we can now simulate things which are either too dangerous to do, let's say like a nuclear explosion. You will never do this somewhere in the desert. Okay, they did it, but you will never do this, let's say, when people can get harmed, or car crashes, or let's say how a tsunami evolves, etc. And these are the things which are much easier to understand when you use simulation on a high-performance computing system. So if you look at a small scale of people, or let's say a small population, it's still easy to do this with a normal computer, to say, okay, how they behave, what they do, what are their connections. But if you use HPC, you can, let's say, make this much wider and globally. So you can, let's say, talk about, let's say, countries, country borders. You can talk about even probably over continents, the movement, the distribution of people, the different attitudes, the different behavior. And you can also, let's say, switch on things like, okay, what is the climate area in this region, which has an effect on the behavior of people? Do they have, let's say, holidays? Do they have, let's say, working time? Is it in the morning? Is it in the afternoon? What is the social income of people there? How do they live? What kind of living habits do they have, etc. And the good thing is, let's say, of course, you can do some small simulations on workstations, which is fine and lead you to some result. But the more, let's say, parameters you can feed into the system, the more calculations you can do. And with HPC, we have the potential to evolve this step by step to really, at a while, then bring in all these parameters and calculate it in, let's say, in a reasonable time frame. People are usually talking also about potential real time. So if you have a pandemic outbreak or something like this, it would be nice to have quick results about the potential prediction of this outbreak. If it takes then 3 months, then usually the outbreak is over and you cannot work with the results anymore. So the next steps is to evolve the tools which we already have, to see in how far they fit to current, let's say, HPC or high scalability systems, to understand how we can proceed the data which is also generated by the simulation. So we have a constant workflow. We simulate and we get, let's say, data out of the simulation, and we can feed the simulation, the data back into the simulation. We also have to see in how the whole, let's say, ecosystem around HPC evolves. So high performance data analytics, which is very important because we get massive data sets. We get massive, let's say, parameters to take into account, and we have somehow filtered them. We have to find the really important bits. We have to find what we call the unknowns, which are the things which are hiding somewhere in the data, and we don't know yet that they are. So we need probably some kind of machine learning algorithms, cognitive analytics. So things which help us going forward. And the good thing is the HPC domain evolves, the ecosystem evolves, and so we can also evolve the global system science community with the support of our tools.